So let's take a look at a basic work energy problem. Suppose I have an object and work is done on it. I know from observations and measurement the conservative work done on it is -6 joules. A result of the work done on the object is a change in the object's kinetic energy being 4 joules. So what we're going to do is I want to find the change in kinetic energy, change in potential energy, change in total energy of the object. I want to figure out what is the total work, the conservative work and non-conservative work done on the object, and the total work, conservative work, non-conservative work done by the object. So what we're given here is that the change in kinetic energy is 4 joules and that conservative work done on the object is -6 joules. So first I write down my work energy relationships and then my relationship of total work with the conservative and non-conservative work and my change in energy relationship to kinetic and potential energy, and then the fact that the work done on an object is equal to the negative work done by an object. I know that the total work done on an object is equal to the change in kinetic energy of that object, which is 4 joules because I was given delta K. I know negative delta U is equal to W sub C, which is -6 joules because I told you that, and that should be on. The conservative work done on an object is equal to the negative change in potential energy, and it's given that the conservative work done on the object is -6 joules, and so delta U is equal to 6 joules. The total work is equal to, on an object is equal to the conservative work done on an object plus the non-conservative work done on an object. I know this is 4 joules and that's -6 joules, and so therefore I can find the non-conservative work to be 10 joules. And I can double check my work by looking at my energy relationship there, because I know what the change in potential energy is, I know what the change in kinetic energy is, and so that should be equal to the change in energy, which should be equal to the non-conservative work done on that object. And so we basically summarize our answers down here: change in energy of the object, the work done on the object, and the work done by the object. Now, I know that the kinetic energy is greater than 0 because it was 4 joules, so the object's speeding up. Since the change in energy is not 0, energy is not conserved in the object, so there must be some non-conservative work being done. And my change in potential energy is also positive, which means that an N example is the fact that I have an object and I just lift it up into the air. I'm increasing the gravitational potential energy, or I could attach it to a spring and push it on a spring, and the spring changes, either stretches or gets compressed. So if I look at the place where G is equal to 10 meters per second squared, and just let the mass be 1/2 kilogram, so the weight is 5 newtons. If I lift up an object 1.2 meters with a force of 8.3 repeating newtons, well, let's see if that matches it. My change in potential energy is gravitational potential, and that would be equal to the weight, mg, times the height, or the change in height, which is 6 joules. And then my non-conservative work is the non-conservative force times the displacement, and I know my non-conservative work is 10 joules because that was what was in the problem, is equal to the force times 1.2, and then work out the math, I get 8.3 repeating newtons, and so this scenario matches the initial problem that I gave. And that's just a basic work energy problem.